Right, so we are recording now. For those who have not yet joined, the recording is there so that you can revisit these concepts and watch it in your own time. Okay, right, let's just do a brief summary. We've already done the introduction to angles being equal, lengths being equal, as explained on page 153. That's what this is, page 153. And underneath 153, underneath that example, explanation, there's example 6 in which they clearly explained how you may then look for the angles that are equal and state them. Then on page 154 and 155, we get our cases to prove. How to prove congruency. So whenever you see me make these lines, you know I'm talking about congruency, okay? Now I'm just going to briefly bring them up again. And this time we should know them quite well now because we've worked with them already. So we've got scenario 1 is our side, side, side. Scenario 2 is our side, angle, angle. You are allowed to use this sharp edged indication for an angle. And then we have the third scenario, the very important one. I'll write it in red because it has to be an angle included in between the two sides, inclusive angle. And then scenario 3, which also very particular, it has to be we call it the RHS, as I discussed last week. It is the right angle, the hypotenuse, and a side. So that 90 degree there, we must see that 90 degree. We must have the hypotenuse. Okay. So in each case, we've got certain things that need to provoke that eyes opening up. We have to open our eyes and we need to spot it. We need to find it. We need to verify it. Right. So along here, you will see I've now just shown you what exercise 3 looks like for those who have not yet maybe looked at it. And exercise 3 is just a very basic way in which we can then look to apply our 4 scenarios. That's basically it. We want to learn how to apply these 4 scenarios, okay? So then let me just move this a little bit. Then what I'm going to do is I'm going to put our scenarios next to us. And then we're going to just try and work through these triangles using our scenarios that is applicable, right? So we are going to see, what do we see at number 1? What do we see at ABC, right? Blown up a bit just to make it nice and clear. And I'm going to write on this, okay? Right, here we go. So I can see that we have, I'm always going to work in color because what I see and what's given to us needs to be indicated clearly. So I'm always going to color things for you. I'm always going to introduce the aspect of finding what's equal, what's identical, so that color coding can help you. So use your highlighters, use the colors at hand. Let's find, okay, I see here is a length for AC. Okay, I see that. Here's also then a length for that's 6 centimeters. Sorry guys, I just want to get comfortable, yeah? Then let's color code that green. Right, and then let's find something else that we have in common. I see an angle. Okay, so what I can do here is for this question, exercise 3, number A, it looks very simple because we have in fact 2 sides that are given and we have an angle. So for each pair of triangles, state the case of congruency that can be used to prove. So here we are just stating the case of congruency. We are just stating, okay? We are not proving. We are not doing that whole in triangle, this, and triangle. We are merely making a statement, okay? So I want you to focus on finding either scenario 1, 2, 3, or 4. That's it. So I can see in triangle ABC. Okay, I've got the side and I have a side. Okay, so there's the side. And what else do I see? I see an angle. And then I see two sides. So I see a side, but I see an inclusive angle, and I see a side. And that's basically side, angle, side, side, angle, side. That's where we get that inclusive angle. So that's number A. Number A, yes, triangle ABC. Try now to also just guide your labeling of the triangle. Try and see angle A is equal to angle D, okay? AB, side AB. Side AB is equal to side DE. So this is how I actually establish the order of that triangle. So it's going to be DEF. Okay, later on we work a lot with the concept of stating the sides like this in order, because those are the sides that have equal lengths, and then finding which angles are then in fact the same. Okay, because if I put it in this order, then angle A should rightfully be equal to angle D. Angle C should then be equal to angle F. And that's later on where we really just get into depth with congruency. Let's try this next one at number B. Okay, in number B, I can see what do I see already is the fact that I can again color code, and I can find, look, I've got this 39 here, 39 centimeters, 39 centimeters. What else do I have? I have a 52 centimeters and another 52. And hey, look at that. I've got another 53 there and a 53. So this is in fact then a scenario where I've got a side, and a side. So all good. Yes, it's one of my scenarios. There it is. It's this one right here. So basically, I don't have to really stress about it. That's great. I can continue. It is legit. Therefore, triangle. Now, let's just always try alphabetical order for the first triangle, ABC, is congruent to triangle. Now, let me go and find what is angle A equal to. If I now go into detail, spotting what I'm looking at, then I'm looking at this angle here, which is between the 52 and the 53, right? Which means this angle should then be equal to that one. And if I look at angle B sits between the 53 centimeters and the 39 centimeters. Therefore, that angle is the same as this angle E, between the 53 and the 39 centimeters. And from here, I can definitely clearly see I've got that situation, which we already saw last week. It's called vertically opposite angles. So C should be in the correct position according to C. So that's already giving you a hint. Your labeling of your triangle ends with the letter C. So A, we said, was equal to D. B, we said, was equal to E, and C must be equal to C. Great, there's my reason. Side, side, side. Perfect. Okay, now let's continue. Let's look at the next one. Okay, we've got number C on the side here. Ooh, the first thing I see is, I've got a 90 degree. I've got a 90-degree triangle. There's my 90 degree. What else do I have? I have a hypotenuse. Oh, wow, it's all coming together now. And then what else do I have? I've got this indication here, which means this length is in fact the same as that length. Those two strokes are equal to those two strokes, which means let's run through it. If I were to say, okay, let me test, is this in fact a side, an angle, and a side? Because that's what I'm seeing. I'm seeing two sides. And I'm seeing one angle. But is this true? This is not true for this one because it does not include an inclusive angle. It is not like this one where we had side, inclusive angle, side. So no, I cannot use that. I will erase that and I will go back to what should I have looked for? I should have looked for the idea that I could possibly be working with scenario number 4 now. This is a nice example of how we define the difference, and I've got a right angle. Have I got a right angle? Yes, I've got a 90 degree. Have I got hypotenuse? Yes. Have I got a side? Yes. Therefore, triangle. Let's try and keep it alphabetical for that first triangle. RPQ, PRQ. What's the alphabet? I'm so bad when I have to come to alphabetical order, but anyway, MNO, PRQ, right? So PRQ, and it's going to be congruent. So I just first state that first one. If you've got the first triangle stated, then you're going to be able to figure out the next one. And I'm looking specifically at Q because Q is my 90-degree triangle, my angle, 90 degree, which means this triangle that if I finish stating it must end in an E, because the order is angle P must be equal to angle D then, angle R must be equal to angle F then, and angle Q to E. Therefore, we can see with the second triangle, it is not in alphabetical order. Alphabetical order would have been A, B, C, D, E, F, D, E, F. Do you understand? Therefore, you must be very, very attentive for when you make the statement. Don't just blindly write the triangle down, but look for the order in which you are writing the letters. It's always best to just, like I said, write that first triangle in alphabetical order and then use the first order, the order of the first triangle. Use its order to help you find the order of this one. Right, now let's look at number D. Let's make that one orange. Okay, number D. Number D, I can see certain things have been indicated. Let's color code again. I can see I have a dot here and a dot and a dot. That means the measure, the size of that angle is equal. Then let's look at something else. I can see there's my little indication of a line, And what else do I have? I can clearly see there's vertically opposite angles. If we don't know what they are by now, then we must still go and revise a little bit more. Vertically opposite angles. Let's see if this is in fact a fact for congruency. Let's write it down. We have an angle, we have a side and an angle, right? So we have a side and an angle. Yes, that is in fact here at this one. Side, angle, side, angle. Great. So when I have my two angles, they can be positioned anywhere. And one side, then I can make the statement. Therefore, triangle. I'm going to do the first triangle again, just alphabetical order, is congruent. Sorry, that's not, let me just get rid of this. I need to write the C's correctly, otherwise it inserts its own shapes. A, B, C, there we go, congruent to triangle. Now, angle A is equal to angle D. I can see that from what's been indicated here. And angle C is once again going to be equal to angle C, which means the order now for the second triangle is D, E, C. And there my reason is side, angle, angle. Okay, right, let's look at the next one. We can see, okay, great. Angle E, number E. These are often triangles where you can immediately pick up on your vertically opposite because of this. You immediately pick up on the vertically opposite here. So this is where it's happening, okay? And what else do we see is in this one, we actually have parallel lines. So with parallel lines, we see that we have alternate angles, and that's something that you need to pick up now. You need to be awake for this. We have alternate angles. So that's our first little, we spot that. And then the fact that I already said we've got vertically opposite angles. And what else has been given? It's been given to us that we've got a 35 centimeter line here and another 35 centimeter line there. Great, which means we can actually go ahead. We've got two angles. And we have a side. So we have side and an angle and an angle. And that is that second scenario again. So therefore, triangle, okay, A, B, C. I'm just doing the alphabetical one first. A, B, C is congruent to triangle. Now let me just quickly see. I've got triangle A. I've got Angle A must then be equal to, because this is also alternate. Okay, so angle A is equal to angle D. Angle B, angle B is equal to angle E. And angle C is always equal to angle C with this vertically opposite. Okay, what is my reason? My reason is angle, side or side, angle, angle. I've got one side and I've got two angles in common. Great. Right, now, what do they say here? At number F, we see we've got something. Oh, be careful here. So, wow, okay. Let's be careful because we need to spot something, obviously, that they've now indicated here. Okay, so what would that mean? That would mean that we have to just check. Okay, let's just quickly make a little summary. I've got a 46 degrees and a 46. Here's 3 centimeters. 3 centimeters. Here's 8 centimeters, 8 centimeters. Ah, I see something. If you look at purely just, oh, I've got a side and I've got a side and I've got an angle, but in B, we only use these three in a combination where it's side, angle, side, because it has to be the inclusive angle. Is 46 the inclusive angle? No, not inclusive. So you simply say, therefore, triangle ABC is not congruent to triangle DFE. Okay, because this is not right. It has to be the inclusive angle, and it's not the inclusive angle. Great. Right, so that basically sums it up for you for that section. They have given you a hint here, and if you guys have any questions that you wanted to pop up, you must please say so, because you have probably worked through this. I'm hoping that you've understood it, and you've now seen your two scenarios where you need to really watch out. The most important scenarios that we do have mix-ups with is what we've seen now, is with this RHS, right angle hypotenuse side, and the other one is with side angle side. So just work very carefully that you don't get confused with those two. Okay, now you will see the rest of page 155, basically just taking you through triangles, example 7, and showing you how you have corresponding sides and angles. Those have all been indicated in words and letters, okay? But if we look at something like we have on page 156, then we've now already covered that. The extent of these ones, you will see this is where you just label them. And then from page 157 onwards, we will focus more on that proof and where we make the statement and our reasons. So please, you must always remember, in geometry, we need this idea of making a statement and backing it up with a reason, okay? This is statement, reason, and this creates a system that we call proof. So it proves, therefore, what statement you're going to make. If or what findings you're going to make. If this statement is correct, but the reason that validates the statement is not correct, then the whole finding is incorrect. You have to make the correct statement with the correct reason to have your validation correct, okay? This is very, very important because this is how we can lose a huge number of marks in congruency very quickly. And if your statement was perhaps incorrect, but your reason is correct, your ultimate finding is still incorrect. So this is one of those cases where you just have to be correct. Everything has to be correct. The statement has to be correct. The reason has to be correct. Your finding is therefore correct. And if your finding is correct, your proof at the end will be 99% there. Accuracy is the big thing here. So when we prove that triangles are in fact congruent, we always look for what we can see. And I'm going to just redraw what I have on my page 159, just as an example of exercise 4, because the worked examples you guys can all look through. Example number 10, example number 11. You need to look through them. Look and work through these examples. Number 10 and number 11. Very nice way of showing you how to use your statement and reason and what to look for in congruency. But now that you've kind of got all those things going, by the time you get to exercise 4, number A, for example, then we're going to see, okay, we want to now show the marker that we know what we're doing. Number 1 states, prove that triangle ABC is congruent to triangle DEF. What I need you to know from the very beginning is that this order is not necessarily the correct order. They are still asking to prove here. By the end of your proof, you must check your order. Because if you have now just gone and write down this statement as it was given, you are not going to get full marks, okay, if you don't check your order at the end. This is essential. This is really, really important. You need to pay attention to that order, because once you've done all this work, once you've gone through all these things that you've now stated, you don't want to get it all wrong because you get your order wrong. You want your full marks. You've done a lot of work for it. Right, so let's look at exercise 4. We have 2 triangles. And they're given as, there's a 70 there, a 70 there. There's a 35 centimeters there, a 35 centimeters there, and there's a 35 angle here, and a 35 angle here. Okay, A, B, C, D, E, F. Let's start in triangle A, B, C, and triangle. Your order here is not very important. Just write it down as it's being given in. And make sure you follow our steps that we said. We said we must state 3 things. Write your number 1, 2, 3 down. Get them all going. Write it in order that you know you're going to make your statement for whatever is in this triangle first. You're going to first show what is in this triangle. Whatever happens in this triangle is equal to whatever happens in this triangle, okay, in that order. And then you're going to round it off with a little help here on the side as to whether it is a side or an angle, okay. This is like your little proof for yourself to help you find which scenario would you then use. Which of these 4 would be applicable here, okay? Right, and we want to also still follow our layout as we have here. Statement, then reason. Okay, so if you want, you can do a little diagram for yourself and work within it, and you can try and force yourself to do that statement and reason, just because it is a good technique to master now, statement reason. And the first thing I'm going to state is that I see in triangle ABC that angle, that side, let me start with the side, that side AB is equal to side DE, and that clearly has been given. And what is it? It is a side, for my understanding. Then I see an angle B being equal to angle E, and you can say it's equal to that if you want. That's also been given, but that, for my understanding, is an angle. And then I go back and I see, okay, great, I've got another angle, C, equal to F. And that has also, in fact, been given. Quite a simple one, but what is it? It is an angle, right? It's an angle that's been given. So let me now finish off this proof. Can I validate that this is, in fact, a scenario for congruency? Side angle, angle, is that, in fact, one of my four? Ah, yes, perfect. Right, let me just do this quickly. I'm just going to copy this, and then just let's add it here so we just know where are we taking it from. Oh wow, I just copied it hasn't copied the content. Okay, that's new. Then let me just do this. Okay, just so that we have the theory right there in front of us, so that you all know what am I talking about when I do this. I am talking about this. Here's our proof. It's like your little go-to summary page. You always need this in front of you to validate whether it is right. Okay, now, which scenario do I have? I have a side, I have an angle and an angle. Great, that's true. Therefore, triangle ABC, now I must go in order, right? Is congruent to triangle. Okay, so angle A must be equal then to angle D, I see. Angle B is equal to angle E, and angle C equal to angle F. Great, so that's fine, but I'm not done yet. I must state what scenario am I referring to. Great, there it is. Now your second part of this question, this was just number one, A number one. Now A number two states why then? Why is AC equal to DF? Now, what did I say right in the beginning? Can you remember that I said when we work with a triangle, we must be able to cut it out and paste it on top of this triangle to prove that it's congruent. Therefore, we have now proven that these two triangles up here are in fact congruent. And if they are congruent, then I can paste them on top of each other. And I can find that angle A will be equal to angle D, which would be the result, the sum of the angles of a triangle. That angle B already is E and C is already F. But also that this length right here is in fact equal to A, B, and DE. And then this length, DF, equal to AC, and this length, DC, equal to EF. And this is where you then take your understanding one step further and then deduce, therefore, AC is in fact, see what I'm doing here, let me just do it green, AC is in fact overlapping and equal to DF. F, because they're sharing the same length. Therefore, AC equal to DF, because, okay, our period is up, because of triangle ABC congruent to triangle DEF. It means your triangles have been proven congruent here. Therefore, you can now state that the other sides are in fact equal. Right, guys, so that wraps it up for today. I'm going to